Tank is a strategy game where the first player to have the opponent to be limited will win the game. It is a 2-minute fast-paced game where players can destroy certain walls to obtain buffs before deciding to confront the other player. All walls inclusive of the buffed ones will spawn at the start, and only certain buffed walls can be destroyed to provide extra stats. There are certain walls that will debuff the player when receiving a hit, such as reducing the speed of the player or reflecting back damage, and reducing the health of the player, which can be a death sentence. This slide provides an overview of the finalized UML diagram. In the diagram, the major classes in the gameplay is as shown, where the state and gameplay.mouse input extends from the gameplay class. This is necessary to ensure that the game runs. For the tank and bullet classes as shown in this slide, the entity is the major class that extends the tank and bullet as its main responsibility is to oversee their operations. From the tank class, texture and animation is required to ensure that the class runs smoothly. For the movement class, it relies on java.awt.event in retrieving the keyboard input and outputting the sound class. This is the core object interaction for the game. In the war class, it is managed by the entity and extends to multiple child classes as well as the entity controller. This is because the child classes requires the information that the parent class contains, and the war classes also illustrates polymorphism. The war classes is a core object in the game that interact with the other objects such as the tank and bullet classes. Under the limitation and scope for improvement, firstly, there's limited arena layout. The players can design their own arena by modifying the code. Presently, Tank does not support storing multiple arena maps within the game. As a future improvement to the game, players should be able to choose the arena from multiple selections for their matches to make the game more interesting. Secondly, there is fixed tank and war spawn points, which make the game more predictable. To improve the replayability of the game, developers can spawn the tank in a location after losing a heart, providing the player a chance to turn around the game. Wars can also be spawned at random timing to enhance the strategy element. Lastly, there's a visual bug when keys are simultaneously pressed. If the player is moving left, using the left arrow key and simultaneously pressing the up or down button, the tank will remain in the up or down orientation. To fix this, the affected player must release the key that moves left and press it again. Under the special features and highlights of the game, developers have went the further mile to deliberately design the GUI to be simple yet aesthetic to the game theme to enhance the user experience. The GUI implemented includes the main menu, where players can mute the game music and view the match history. To further accentuate the ambience of the game beyond visually appealing, game music have been implemented with sound effects to engage and deliver information such as whether damage have been taken by players. A leaderboard, also known as a match history, is implemented in the game, prompting the winning player to input his name. The potential of the leaderboard is to encourage competitiveness between two players where they can keep tabs of the scores and enhance the game's replayability. And visual animations are also shown when the player collides with the opposing player's bullets to provide a more immersive user experience. The pause state has been implemented to allow players to pause the game when they have an urgent task to complete and to be able to resume the game at a later moment when they are available and wish to continue playing. The libraries and API used in the game project can be seen from the slides. Java.awt is the abstract window toolkit API used to create the main graphic user interface known as GUI for the game. JavaX.swing complements with lightweight GUI components such as the J button, J text view, and J menu. Java.awt.graphics allows drawing onto components on devices and off-screen images. It also encapsulates the information required for the basic rendering operations. Java.awt.image.bufferImage is necessary to handle and manipulate image data, which is used for the sprites in the game. JavaX.swing.imageIcon is used for the implementation of icon interfaces that paints icons from images. The images are created from the file name or byte array that are preloaded using the media tracker to monitor the loaded state of the image. Java.new.file.files is excessively used for static methods that operates on files and directories. In the game, it allows local directories to load and save the high score for the leaderboard. Java.awt.event.keyEditor is necessary to create an abstract editor class to receive keyboard events. Lastly, JavaX.sound.sampled is used to provide interfaces and classes to capture, process, and playback of the sampled audio data, which is used for the game music.
Encapsulation is a concept of OOP, and it grants developers greater control over different attributes by having the ability to set them at specific times as required. It also allows data to be hidden from other classes, avoiding the situation where they could manipulate the attribute directly. We have used encapsulation in files wall.java and tank.java, as you can see from the screenshots, which consists of private attributes and their get and set methods.
As for the inheritance concept in OOP, we have created a parent class named wall, and it consists of attributes such as index, coordinates, and image. These attributes are necessary for initialization. Child classes such as aluminium, carbon, diamond, gold, and moissanite wall, they all inherit the attributes from their parent class, which is the class wall. And the child class would have to extend to the parent class in order to make it known that it is the child class of that particular parent class. So in this case, for example, aluminium wall class would have to extend to wall in order to inherit the attributes in that class.
Moving on to polymorphism, the way we have implemented it into our game is through overriding the methods of a parent class. For instance, overriding occurs when the Dynamo Walls implements its own version of the collision method, such that when the player that shoots this wall, they will get their health reduced, as opposed to the fact that if a child class were to inherit the collision method without overriding, the player that shoots this wall merely gets their bullets removed upon collision. Similarly, the child classes that implement the entity interface inherits the abstract methods such as the getHitbox method, which gets overridden according to their dimensions in the game.
I'm going to talk about the abstract class that's being demonstrated in our project. So our project consists of different types of walls, such as steel wall, aluminium wall, etc. And all of them share some common attributes, such as XY coordinates of the wall, image icon restores image. It also contains default method implementation, such as collision detection. Simultaneously, we wish to have different effects when the walls are being shooted by a specific player. Thus, we created an abstract class named wall to serve as a base for subclasses to extend, so that it can use or override the implemented methods in the abstract class. An example demonstrated is a common method, which draws out the different type of wall. This helps in generalization of its methods and provides code reusability.
Methods defined in an interface are empty but must be implemented by other classes. For our project, the classes that implement the entity interface are tank.java, wall.java, and bullet.java. Each of these entities behaves differently from each other, from the way they are initialized at the start of the game to the way they are removed from the game, either through the end of the game or after being shot at. Therefore, the methods in the entity interface are used to determine the frame rate of the game, to render the game appropriately, and to reflect accurately where different entities should be. Return the x and y coordinates of the entities, return the index of the entities to identify what they are, and to return invisible boxes such that collision between tanks and walls, bullets and walls, bullets and tanks can be detected, such that appropriate actions can be taken, such as buff walls being removed after being shot at.
The team also implemented many instances of error handling in the project. We used many try and catch statements to catch an error or exception and handle it according to our desired application outcome. Error handling or exception catching were mainly used in our match history function, which records down previous game scores. As the scores will be saved locally, accessing files with read and write privileges will be required. In doing so, we require the read and write instruction to be surrounded with the try and catch in the event that the file is not available or the file ran into some errors. For example, in our case, when a player launches our game for the very first time, there won't be any past records, and therefore the application will throw an exception that it cannot read the file. We handled the exception by displaying a message that there are no recent matches. We also use the exception function print stack trace, which prints along details like line number and class name where the exception occurred so that we will be able to debug the application easily.